Welcome to our lesson on oxidation numbers. Oxidation numbers are a fundamental concept in chemistry that help us understand how electrons are shared or transferred in chemical reactions. So, what exactly is an oxidation number? An oxidation number, also called oxidation state, is a number assigned to an atom in a compound that represents the number of electrons an atom has gained, lost, or shared in forming chemical bonds. Let's go through the basic rules for assigning oxidation numbers. Rule 1. The oxidation number of a free element is always 0. Rule 2. The oxidation number of a monatomic ion equals its charge. Rule 3. The sum of oxidation numbers in a neutral compound is 0. Rule 4. In compounds, fluorine always has an oxidation number of -1. Rule 5. Hydrogen usually has an oxidation number of +1, except in metal hydrides where it's -1. Rule 6. Oxygen typically has an oxidation number of -2, except in peroxides where it's -1. Now, let's look at some examples to understand how to assign oxidation numbers. First, let's consider sodium chloride, or NaCl, which is table salt. Sodium forms a +1 ion, so its oxidation number is +1. Chlorine forms a -1 ion, so its oxidation number is -1. And as per our rule, the sum of oxidation numbers in a neutral compound is 0. +1 plus -1 equals 0. Let's look at another example, water or H2O. Hydrogen usually has an oxidation number of +1 in compounds with nonmetals. Oxygen usually has an oxidation number of -2. So we have two hydrogen atoms, each with oxidation number +1, and one oxygen atom with oxidation number -2. The sum is 2 times +1, which is +2, plus -2, which equals 0. This confirms our rule that the sum of oxidation numbers in a neutral compound is 0. Now let's try a slightly more complex example. Iron oxide, or Fe2O3, which is commonly known as rust. We know that oxygen typically has an oxidation number of -2. There are 3 oxygen atoms, so that's a total of -6 for all oxygen atoms. The compound is neutral, so the sum of all oxidation numbers must be 0. This means that the 2 iron atoms must have a total oxidation number of +6. Since there are 2 iron atoms, each iron atom must have an oxidation number of +3. We can verify 2 times +3, which is +6, plus 3 times -2, which is -6, equals 0. Oxidation numbers are particularly useful in understanding redox reactions. Redox is short for reduction oxidation. Oxidation is the process where an atom loses electrons and its oxidation number increases. Reduction is the process where an atom gains electrons and its oxidation number decreases. Remember the mnemonic. Elio the lion says GER. Loss of electrons is oxidation, gain of electrons is reduction. Let's look at a simple redox reaction. The reaction between zinc metal and copper chloride. Zinc plus copper chloride yields zinc chloride plus copper. Initially, zinc has an oxidation number of 0 because it's a free element. In copper chloride, copper has an oxidation number of +2 and chlorine has -1. After the reaction, zinc now has an oxidation number of +2 in zinc chloride, and copper has been reduced to its elemental form with an oxidation number of 0. We can see that zinc's oxidation number increased from 0 to +2, so zinc was oxidized. Copper's oxidation number decreased from +2 to 0, so copper was reduced. To summarize, oxidation numbers are a powerful tool in chemistry that helps us track electron transfer in chemical reactions. They help us identify which species are being oxidized and which are being reduced in redox reactions. Remember the key rules we discussed for assigning oxidation numbers, especially that the sum in a neutral compound must equal 0. With practice, determining oxidation numbers will become second nature, and you'll gain deeper insight into the chemical reactions you study.